So hi everyone, welcome to my YouTube channel. In this video I am going to explain you about the Norton's theorem. So this is the kit for studying the Norton's theorem. So Norton's theorem in direct current circuit theory, which is also known as Mayer's-Norton theorem, is simplification that can be applied to network made of linear time invariant resistance, voltage sources and current sources. So the instrument comprises of the following built-in parts: 2 meters for measuring voltage and current, 1 variable power supply of 1.2 volt to 15 volt range, and 1 resistance network printed on this board, a variable load resistance. So the variable load resistance range is 100 ohm to 600 ohm. So here is the manual. So we have to follow the procedure here. So first let us make the connections here. So DC power supply, we have to connect positive terminal to the positive terminal of the DC power supply, and then negative terminal. Using patch cords we have to make connection. So negative terminal of the DC power supply. This is for the connection for voltmeter. And next we have to connect the resistance network here. So here it is completed. Resistance R2 has been connected. So load resistance we have to connect. So negative terminal to the negative terminal, and then positive terminal to the positive terminal of the load on the circuit. So actually it is inbuilt, already connected. You can make connections by connecting it to the load DC power supply. That we have to look the circuit such that we should not include the load resistance. So here we can see the voltage is about the 1.2 range is 1.2 volt to 15 volt they have given. When we switch on the device, the deflection we can see in the voltmeter at 1.2 volt, and the ammeter reading in terms of milliammeter 5 milliammeter, near to 5 milliammeter. So first we should follow here the procedure, that is you can see in the manual. So connect the 12 volt in the circuit as shown in figure. So already we have made the connections. Here we need to find the two values, Norton current and Norton resistance. So here for that what we have to do here, so we have to see the circuit from. So for the study of Norton theorem we have to find out two values here. One is Norton equivalent resistance and another one Norton equivalent current. Here is the circuit diagram when we are not considering the load resistance, when we are looking only at the two terminals here. So this is resistance network. We can calculate here Norton's resistance, so we can call that as internal resistance. Here on the apparatus also you can see R1, R2 are connected in series and R3 is parallel connected. If we consider R1 and R3, they are in parallel, they are connected in series with R2. Then formula for the internal resistance we can write like this. Internal resistance is equal to R2, which is in series with the R1 and R3 which are in parallel. R1 R3 divided by R1 plus R3. So values they have given in this diagram. Substitute the value of resistances R1, R2, R3. So you will get the internal resistance, that is Norton resistance. It is about 398.75 ohm. Okay. So next here is to find out the Norton short circuit current. We can see here the circuit diagram on the apparatus. So here we are considering the circuit not including the load resistance. So at that moment we are not applying any load resistance. What is the current that flowing across this R2, resistance R2, we have to find out. So if we consider the circuit like if we consider R2 and R3, they are in parallel connection. So R2 and R3 are in series with R1. So the equation becomes for resistance, so internal resistance. Find out the current here. So the equation becomes voltage by current. So DC power supply we have considered here 10 volt, and as we have considered the network R1, R2, R3. So R1 is in series with the connection for R2, R3 which are in parallel connection. So the formula will become like this. So R1 plus R2, R3 by R2 plus R3. Then substitute the value of R1, R2, R3 they have given. So once you substitute and calculate, you will get the current in terms of milliampere, 0.043 milliampere. So this current is used to calculate the Norton short circuit current. So here is the formula, current into R2 by R2 plus R3. So this current is in parallel with the connection here for this connection R2 and R3. So then the value of short circuit current for the Norton's theorem, that is 17.2 milliampere. So once we get the value of Norton resistance and Norton short circuit current, we can calculate the load resistance. So we have to consider in the circuit the load resistance. So how much load we apply, we have to calculate the corresponding load current here. So for the constant power supply of about 2.5 volt, for different load resistance you can see the ammeter reading here for 100 ohm, 200 ohm, 300 ohm, 400, 500, 600. So the current is going to decrease as the load resistance increases.